Hello, my name is Petr Cervenka. I am PhD student from Czech Technical University in Prague, and I would like to tell you something about my research, which deals with steel fiber reinforced concrete slapping compression in steel concrete composite frame joints. This research I am doing with Dolejs. Here you can see content of my presentation, state of the art, possibilities of occurrence of compressed slab in composite joints. First, unbalanced negative moments. Differences in joint forces are carried by column and adjacent concrete slab is compressed. Second, in case of column failure. Before occurring a membrane state, there is joint above failure column loaded by sudden bending moments and normal forces. Third, in case of seismic action. There are two load-bearing mechanisms defined in Eurocode 8, Mechanism 1 and Mechanism 2. Mechanism 1 is direct compression of slab by column flange. Mechanism 2 is defined by struts and tie mechanism, where concrete struts compress concave part of column. Inclination of concrete struts is assumed 45 degrees. On the basis of these two mechanisms, there is defined formula for calculation of effective width of concrete slab in compression in composite joints, where h and b are cross-sectional dimensions of column. The standard procedure for calculation of effective width is not accurate. Resistance of mechanism 1 should be greater because of a confinement effect caused by restraints. Lateral restraint is caused by direct bearing of column flange and continuity of concrete slab around column. Vertical restraint is caused by transverse reinforcement. Some research says that the value of compressive strength could be assumed higher by 30%. In standard procedure, there is assumed inclination 45 degrees of concrete struts of mechanism 2. But some researchers says different value, for example 30 degrees. Goal of this research is to derive more accurate formula for calculation of effective width of FRC slab in compression in nodal zone with assumption of confinement effect and more precise inclination of concrete struts. Procedure of research is following. Experimental and parametric study with validated numerical model should lead to analytical solution. There is shown test configuration, test frame and tested specimen with main dimensions. Way of the loading of the joint is shown in a figure on top of the slide. Preparation of experiment. Joint was designed by component method. Design of joint should assure that the sudden moment resistance will be the critical resistance of whole joint. Here is some photos from experiment, slab reinforcement, and photo before starting experiment. Measurement. Stake gauges were located on top of slab, which is described on this figure. There are strain gauge rosettes to measure inclination and stress of concrete struts. Digital image correlation method was also used for this purpose. Transverse and longitudinally oriented strain gauges are located to measure longitudinal and transverse forces of mechanism 1 and 2. In figure 19, there is location of strain gauges on reinforcement. Right side of slab is loaded by holding moment and left side by sudden bending moment. In figure 20, there is location of displacement sensors and inclinometers for independent measurement of rotation of the joint. There you can see some photos of measurement, inclinometers, strain gauges and displacement sensors. Upon tests were performed, here in the table are average values. Cubic compressive strength of FRC was higher than 60 megapascal. Single strength in compression was 45 megapascals. There are main test results. Experiment had two parts. Apply and gradually displacement to 60 millimeters. After that, then load and then apply and displacement to 100 millimeters. Hydraulic jack for hogging moment can apply maximum 100 kilonewtons. So, in the relationship between the moment and the rotation of the joint, in holding moment, you can see constant moment 184 kilometers. Here you can see the relationship between the moment and the rotation of the joint. Again, inside the moment area there was MP plastified, crashed concrete slab in front of column flange, and slab cracks were observed due to big rotation of the connection. They are displayed normal deformation from first part of the experiment. Normal deformation was measured on top of the slab in different distance from column from flange. In the distance 75 mm, there is strain gauge row number 6. Here. In the distance 290 mm, there is strain gauge row number 4, and in the distance 500 mm, there is strain gauge row number 2. You can see shear lag here and here. You can see formation of concrete struts here, here, and also here. A symmetric form of this graph is because of asymmetric specimen due to imperfectional shape of column cross section. The deformation in front of the column flange exceeded the compressive strain in the concrete at the peak stress, which is 2.4 per mil, according to analytical calculation for common concrete. There is displayed normal deformation from second part of the experiment. Local damage of the concrete slab in front of the column flange leads to degrees of normal deformation here. After that, normal deformation of concrete truss increased. The deformation in front of the column flange exceeded the ultimate compressive strain in the concrete, which is 3.5 per mil, according to analytical calculation for common concrete. But there was no permanent deformation at that place of the strain gauges after the test by visual observation. Principal direction and minimal principal deformation value caused by mechanism 2 was measured by the digital image correlation method on this area next to the column. Principal angle was determined between 35 and 40 degrees. Minimal principal deformation achieved the compressive strain in the concrete at the peak stress. Here is the distribution of the normal deformation on the concrete slab reinforcement at the level of the connection. Numerical models created in program Athena Science. Material model of fiber reinforced concrete was validated by iteration process with 4-point bending of steel fiber reinforced concrete beam. On the basis of experiment results, tension function is iteratively found. Measured material properties are used. Model is not validated yet. You can see differences between the graph of relationship bending moments to joint rotation from Athena experiment. Numerical model show higher bending resistance because preliminary modeled contacts of some composite joint components, like plate and bending, concrete slab in compression, and shear stars. They are displayed principal deformation, principal stress, and formation of microcrack on top of the slab. There is shown only part of the slab. In front of the column flange, stress overcome 52 megapascals, so the confinement effect is present. Inclination of concrete studs are between 35 and 40 degrees. The results of the experiment show that the inclination of the concrete struts is between 35 and 40 degrees. Apparently, the confinement effect is present. A larger parametric study will be performed out with validated and verified numerical models to obtain analytic procedure. Thank you for your attention.